When developing learning algorithms, very often a few simple plots can give you a better sense of what the algorithm is doing and just sanity check that everything's going okay and the algorithm is doing what it's supposed to. For example, in an earlier video, I talked about how plotting the cost function j of theta can help you make sure that gradient descent is converging. Often, plots of the data or of the learning algorithm outputs will also give you ideas for how to improve your learning algorithm. Fortunately, Octave has very simple tools to generate lots of different plots, and when I use learning algorithms, I find that plotting the data, plotting the learning algorithm, and so on are often an important part of how I get ideas for improving the algorithms. And in this video, I'd like to show you some of these Octave tools for plotting and visualizing your data. Here's my Octave window. Let's quickly generate some data for us to plot. So I'm going to set t to be equal to this array of numbers. Here's t, set of numbers going from 0 up to 0.98. Let's set y1 equals sine of 2 pi 4t. And if I want to plot the sine function, it's very easy. I just type plot t comma y1 and hit enter. And up comes this plot where the horizontal axis is the t variable and the vertical axis is y1, which is the sort of sinusoid function that we just computed. Let's set y2 to be equal to the cosine of 2 pi 4t, like so. And if I plot t comma y2, what Octave will do is it'll take my sinusoid plot and it will replace it with this cosine function that now, cosine of x starts at 1, right? Now, what if I want to have both the sine and the cosine plots on top of each other? What I'm going to do is I'm going to type plot t comma y1. So here's my sine function. And then I'm going to use the function hold on. And what hold on does is it causes Octave to now plot new figures on top of the old one. And let me now plot t, y2. I'm going to plot the cosine function in a different color. So let me put a r in quotation marks there, and instead of replacing the current figure, it'll plot the cosine function on top, and the r indicates that I want this in a red color. And here are additional commands: x label time, say to label the x-axis or the horizontal axis, and y label value, say to label the vertical axis value. And I can also label my two lines with this command, legend, sine, cosine, and this puts this legend up on the upper right, showing what the two lines are. And finally, title my plot, puts a title at the top of this figure. Lastly, if you want to save this figure, you type print d-dpng my plot.png. So PNG is a graphics file format, and if you do this, this will actually save this as a file. Before I do that, let me actually change the directory to, let's see, like that, and then I will print that out. So this will take a while, depending on how your Octave configuration is set up. This may take a few seconds, but change the directory to my desktop, and Octave is now taking a few seconds to save this. If I now go to my desktop, let's hide these windows. Here's my plot.png, which Octave has saved, and there's the figure saved as a PNG file. Octave can save files in other formats as well, so you can type help plot if you want to see the other file formats rather than PNG that it can save figures in. And lastly, if you want to get rid of a plot, the close command causes a figure to go away. So there's that figure. If I type close, that figure just disappeared from my desktop. Octave also lets you specify a figure number. So you type figure 1 plot t y1. That starts up first figure, and that plots ty1. And then if you want a second figure, you specify a different figure number. So figure 2 plot t y2, like so. And now on my desktop, I actually have two figures, figure 1 and figure 2. That's one plotting the sine function, one plotting the cosine function Here's one other neat command that I often use, which is the subplot command. So I'm going to use subplot 1, 2, 1. What that does is it subdivides the plot into a 1 by 2 grid. That's what the first two parameters are. And it starts to access the first element. That's what the final parameter 1 is, right? So just divide my figure into a 1 by 2 grid, and I want to access the first element right now. And so if I type that in, it's brought up this figure that's on the left, and if I plot t, y1, it now fills up this first element, and if I now do subplot 1, 2, 2, I'm going to start to access the second element, and plot t, y2 will fill in y2 in the right-hand side or in the second element. And last command, you can also change the axis scales and change axes to 0.51, minus 1, 1, and this sets the x range and y range for the figure on the right. And concretely, it sets the horizontal range of values in the figure on the right to range from 0.5 to 1, and the vertical axis values to range from minus 1 to 1. And you don't need to memorize all these commands. If you ever need to change the axis, all you need to know is that there's an axis command, and you can really get the details from the usual Octave help command. Finally, just a couple last commands. CLF, clear as a figure. And here's one more neat trick. Let's set A to be equal to a 5 by 5 magic square, say. So A is now this 5 by 5 matrix. There's a neat trick that I sometimes use to visualize a matrix, which is I can use image SC of A. And what this will do is this will plot a 5 by 5 matrix. So take my matrix, I'll plot this as a 5 by 5 grid of colors, where the different colors correspond to the different values in the A matrix. So concretely, I can also do color bar. Let me use a more sophisticated command. Image SCA, color bar, color map, gray. This is actually running 3 commands at a time. I'm running image SC, then running color bar, then running color map, gray. And what this does is it sets a color map to a gray color map, and on the right it also puts in this color bar. And so this color bar shows what the different shades of color correspond to. Concretely, the upper left element of the A matrix is 17, and so that corresponds to kind of a mid shade of gray. Whereas in contrast, the second element of A, so the 1, 2 element of A is 24, right? So it's A 1, 2 is 24. So that corresponds to this square up here, which is nearly a shade of white. And the small values, say what is that? A45, is the value 3 over here. That corresponds, you can see on my color bar, that corresponds to a much darker shade in this image. So here's another example. I can plot a larger, here's a magic 15. That gives me a 15 by 15 magic square. And this gives me a plot of what my 15 by 15 magic squares values look like. And finally, to wrap up this video, what you've seen me do here is use comma chaining of function calls. Here's how you actually do this. If I type A equals 1, B equals 2, C equals 3, and hit enter, then this is actually carrying out 3 commands at the same time, or really carrying out 3 commands one after another. And it prints out all 3 results. And this is a lot like A equals 1, B equals 2, C equals 3, except that if I use semicolons instead of a comma, it doesn't print out anything. So this, this thing here we call comma chaining of commands, or comma chaining of function calls. And it's just another convenient way in Octave to put multiple commands like image SC, color bar, color map, to put multiple commands on the same line. So that's it. You now know how to plot different figures in Octave. And in the next video, the next main piece I want to tell you about is how to write control statements like if, while, for statements in Octave, as well as how to define and use functions.